When I ask you to think of one of the greatest scientists of all time, you probably have Isaac Newton in mind, right? Well, he's the first person I would think of too if I'm asked the same question. Why not? Newton was only 25 years old when he formulated most of his discoveries in mathematics and mechanics. His book, Mathematical Principles of Natural Philosophy, commonly referred to as Principia, was considered by many scholars to be the most important publication in the history of physics. Long before the time of Newton, scientists had asked themselves, what is the natural state of motion? The early Greek scientist Aristotle had presented a theory that prevailed for almost 20 centuries after his death. According to his theory, the natural state of an object was at rest, except for the celestial bodies, which were naturally in motion. It is easily observed that moving objects, such as rolling ball, tend to slow down and come to rest. So a natural state of being at rest must have seemed logical to Aristotle. In 15th century, Galileo challenged Aristotle's idea. All objects naturally remain in motion, he said. He concluded this after he studied motion using a ball rolling down an inclined plane onto a level surface. He noticed that the smoother he made the surface, the further the ball would roll. He reasoned that if a very long surface could be made perfectly smooth, there would be nothing to stop the ball, so it would continue to slide in the absence of friction indefinitely. After Galileo's death, Newton studies his ideas. He recognized this phenomenon where object remains moving until a force stops it, and he incorporated this in his first law of motion. Newton said, an object will remain at rest or in uniform motion in a straight line unless acted by an external unbalanced force. Before we go deeper with the law established by Newton, let us examine first what he meant by this. Uniform motion in a straight line means that the velocity is constant and that the net force acting on it is zero. If the object is at rest, its constant velocity is also zero. What does he mean by external forces? These are applied forces, one applied on or to the object. Say you kick the ball and the ball moves, the force you exerted to the object is an external force. There are also internal forces. An example is observed when you are inside a moving vehicle. You can push on the floor on the dashboard, but this has no effect on the car's velocity because your push is an internal force. However, let us be clear that because of the ever-present forces of friction and gravity on Earth, it is difficult to observe an object in state of uniform motion. But in free space, where there is no friction and there is negligible gravitational attraction, an object initially in motion maintains a constant velocity. Let us go back again to Galileo. He also introduced another important concept. Let us recall that in his experiment, he noticed that the ball maintained a state of motion and there was resistance to changes in that motion. Similarly, he observed that if an object was at rest, it seemed to want to remain at rest. Galileo called this property inertia, where we can define as the natural tendency of an object to remain in a state of rest or in uniform motion in a straight line. Newton went one step further and related the concept of inertia to something that could be measured, which is mass. We can define mass as the measure of inertia. He said that the greater the mass of the object, the greater its inertia, and vice versa. To help us understand the relationship between mass and inertia, suppose we horizontally push two different people and swing initially at rest. One of them, a very large man, and the other is a child. We would quickly find that it was more difficult to get the adult moving compared to the child. Also, once we get them swinging and then try to stop their motions, it is harder to stop the adult than the child. We can say therefore that being more massive, the man has greater inertia and a greater resistance to change in motion. Because of the relationship between motion and inertia, Newton's first law is sometimes called the law of inertia. Today, we can use this law to describe some observed effects in everyday life. For example, suppose we are in the front seat of a car traveling at a high speed down a straight road and the driver suddenly put on the brakes for an emergency stop. The friction on the seat of your pants would not be enough to change the motion, and your tendency is to keep moving forward while the car was coming to stop. Newton's first law makes a good case for wearing seatbelts in a moving car. To sum this up, we learned that Newton's first law of motion deals with the behavior of an object in uniform motion that tends to travel in a straight line until acted upon by some external unbalanced force. This law is called law of inertia, where inertia is a tendency to remain moving or in motion. We also relate inertia in mass such that the higher the mass, the higher the inertia, and vice versa. That is all for Newton's first law. In the next video, we shall discuss about the second law or the law of acceleration. Once again, I'm Gilmar De Castro, and I hope to see you in the next video.